Okay, this is a video on how to create images for the TART radio telescope using the containerized TART tools. This is available on the GitHub repository under the TART telescope organization called Tools. And the advantage of these tools is that they will run on any platform using a containerized Docker system. In this GitHub repo, which allows you to download the tools, you will need to build them once, and that requires an installation of Aptainer or Singularity, and that's free software that can be installed on most machines. And this is an optional step which I won't be using, to create an alias. And then, in fact, there's some instructions on how to do basic imaging on this repo, and I will go through them. So there are essentially three ways of getting data from the TART telescope. One is to use the console. So here is the Mauritius console. You can tell because different TART telescopes have their console referred to as a different URL. This is MUUDM, the name of the Mauritius telescope. So you can download by going in this console to the raw data files or the visibility files. We'll image from visibility files in this video. And I could just simply download a visibility file and that would work just fine. Another way is to use the TART viewer, which is available here. This is a more modern interface which has nicer imaging and a nice view of the current visibilities, all sorts of nice things about it. And you can once again download visibility data files using the web interface. A third way is to use the TART tools themselves, because one of the TART tools is called TART download data. And this command will in fact download a visibility file. So first of all, I will remove any visibility files in this directory. And now I'm going to run that command. And the way I can run it is I either have an alias or I type aptainer run tarttools.sif and then give it the command, which is tart download data, tell it to download visibilities, tell it to download from that API, and --n1 says download just one of them. If you do that, it will make a web request to the correct API and download a single visibility file. Now, that's not quite enough to do imaging, because that visibility file is a raw data file in HDF format. So the next tool we need to use is the TART to MS tool, which will take the HDF file and will process it and save it as a measurement set. So I'm going to go here and call it TART to MS --HDF and that. Then I will paste in the other options. This says convert it into a single field and rephase it and save it as udm.ms, the measurement set. Now, that visibility file is in fact 60 snapshot images which are each saved as a separate field, so this just combines them into a single field at the average pointing of the TART telescope. Because remember, the TART telescope points straight up, so as the Earth rotates, the center of the field of view moves. So this will make a single field. It takes a few minutes, well, a few seconds, not too long, and this will process the measurement set, will process the HDF database and create, as you see here, it's got 60 frames, and it's going to modify, so compute the new UV coordinates and rearrange the whole measurement set or the whole data set into a single field. Right, that's done. So now if you look, we've got the visibility file, and now we've got the measurement set. If you look inside the measurement set, you'll see it's just a directory with data files in a standard format. So now that the data is in a measurement set format, really all is ready for conventional imaging. And you could use a tool like WS Clean, which is a standard tool. It's used for vast measurement sets. It's not perfect for very wide angle images, but we do have some tools inside the TART telescope tools which are designed for very wide field imaging. And that is the DISCO tool. And here is a command which will create take the measurement set, take approximately 10,000 visibilities out of it, using a 170 degree field of view with a resolution of 30 arc minutes, and an L1 regularization, a lasso imaging technique, will generate a file representing the image. So we can do that by changing this to be the DISCO command. So if you ever need any help on the options, you can just type --help, and it will let you know the command line options. The DISCO tool stands for Discrete Sky Operator Imaging, and it's written by myself as designed for operating on the TART measurement sets. So this command takes the measurement set, lots of visibilities, uses a 170 degree field of view at a reasonable resolution, and these are imaging options, and generates a file which I'm just going to call UDM, just to make it smaller, or shorter file name. This won't take too long. It's a relatively easy process because there's just not that much data inside the measurement set. However, there are 16,500 visibility measurements in combined measurements. So in fact, this is probably not ideal from I've limited it to 10,000 here, so maybe I'll make this 16,000, doesn't really make much difference to the image that's produced, just slightly lower noise when you use more measurements. The images, which is not really enough to get significant rotation of the sky. So, right, now if we look, we will have created udm.h5, which is a relatively large file. It contains all the pixels, just over 1 megabyte. And we can't visualize this file, but there is a tool available for visualizing files, and it's called DISCO Draw. And it will take that H5 file and save it as some other thing. And it has a couple of nice options. If we look here at the options, one of them is to show the known sources, which would, that's the show sources. So that's what we're going to do. So we'll go show sources, just go to show sources, then we'll save it, SVG, and give it the name of the SVG files, save it in SVG format, so we'll call it udm.svg, and that's pretty much all we need, and we just need to give it the name of the udm.h5 file in the final parameter. Run that, it will write an SVG file which we can then look at. So all in all, what we've done here is to use only TART project tools to do the imaging, and in another video I will go through using Clean to do similar imaging. I'll also produce a video showing how to make movies. So if we do this, we've now got an SVG file which we can preview. Here it is. It shows the known sources and an image of the TART sky. So now if we wish, we can convert that, and there's a utility to convert it, let's say resize it to 50% of its original size, of udm.svg to udm.jpg. And that will mean it can be uploaded to the web or anything else. Alright, so that's the small tutorial. Oh, okay, it didn't seem to... Oh, it does seem to have worked. Convert has created a JPEG file, which is quite large, 4,200 by 4,000. I think, yeah, maybe it needs minus resize equals 50% for this to work. But who knows? Overall, this is the way to have a look at the data files.